Hello and welcome to Math 11 Foundations. Today we are looking at scale models. This can be found, the same content can be found on page 479 if you have your textbook. So scale diagrams, they're used to represent smaller or larger objects. So for example, here we have a big triangle and a small triangle. These are what we call similar shapes. Okay? So for a similar shape, each edge length is scaled down or up by the same factor. So for example, if this length we can see is 4 squares wide, this one is, 8 squares wide, this one is 4 squares wide. So you can see the smaller one, if I multiply that 4 by 2, we get 8. Or if I take the 8 and multiply by 0.5, we get 4. Same thing. If I multiply 4 by times 2, we get 8. If I take this length, whatever that length is, times by 2, it would give me that length. And same with this one. This length times by 2 would give me this length. Another thing we need to know about similar shapes is that all measured angles will remain the same. So whatever this angle is, whatever that angle would have to equal to this angle. It's going to be the same. Whatever this angle is, it'd be the same as this top one over here. And whatever this angle is, it would be the same as this other one. Okay? So the main concept for this one is this thing called scale, for this topic today, is this thing called scale factor. We use the symbol K to represent this. So K represents the ratio of a distance measurement of a shape to the corresponding distance measurement of a similar shape, where both measurements are expressed using the same units. So basically what it comes down to is K ends up being a unitless number. So if the diagram is measured in centimeters, for me to find K factor, my actual thing has to be in centimeters as well. If my diagram's in inches, my actual thing has to be in inches as well. If it's in meters, it has to be in meters as well. So basically, we have to see those units cancel out if we are going to use scale factor. So we scroll down a little bit. Right here it says that for reduction, it's going to be a decimal number. So basically, if you see a K value that is a decimal number, it's going to be a reduction. If you see K is bigger than 1, it's going to be an enlargement. So in that above example, we say, let's assume the larger triangle is the original shape and the smaller triangle is the scale diagram. What is the scale factor? Very straightforward. We just write out, okay, we have K is equal to our diagram measurement divided by the axis. So the smaller one had a length, let's say the scores are in centimeters. That's 4 centimeters wide. The other one was, the original was 8 centimeters. So we just get 4 divided by 8, we get 0.5. That is our scale factor. Okay, if you check out the next video, we'll have 2 more involved examples that are a little more challenging than this one.